All right, so today's topic in heat and temperature is topic 5, the particle model and changes of state. So different materials, they expand by different amounts as they warm up, and that's what we saw last class or last week when we were looking at expansion and contraction. The amount of temperature increase when heated is also different in different materials. So for example, if we look at this picture of this beach, right? We have the same hot sun that's beating down on both the sand and the water at the beach. However, the sand warms up quickly. And you've probably noticed that when you walk on the beach and the sand is very, very hot, but the temperature of the water is still cooler. All right, so the reason being is the sand is warming up quickly, whereas the temperature of the water changes much more slowly. Okay, so sand warms and cools quickly, water warms and cools slowly. Why is that? That's because of something called heat capacity and specific heat capacity. So when we talk about heat capacity, definition of that, that's the amount of thermal energy that warms or cools the object by 1 degree Celsius. Specific heat capacity is the amount of thermal energy that warms or cools 1 gram of a material by 1 degree Celsius. All right, so heat capacity describes a particular object. It depends on the mass of the object and the material the object is made of. And the material here, particular material, is still important for specific heat capacity, as well as the material the object is made of. All right, so the reason why the sand on the beach warms quickly is because it has a low specific heat capacity. Water, on the other hand, it warms much slowly, and that's because it has a high specific heat capacity. So I'll just pause here and we'll watch this video here on specific heat capacity. All right, so next we're looking at changes of state. So these terms you're probably already familiar with. Melting is to change from a solid to a liquid. Note here, melting is also called fusion. All right, so just another term to be aware of. Fusion is also to change from a solid to a liquid. To freeze is changing from a liquid to a solid. Evaporating, a liquid is changing from a liquid to a gas. Condensing or condensation, it's a change from a gas back into a liquid. Sublimation, in this diagram, it's showing that sublimation is when a gas changes directly to a solid or a solid changes directly to a gas. But there is another term there that should be there, but it's not showing. There is a term called deposition, and that is the change of state from a gas directly to a solid. And then sublimation is the term for a change of state from a solid to the gas. Okay, and both of those are passing from solid to gas or gas to solid without going into the liquid phase. So here, just looking at some melting and boiling points of some pure substances. So water is on there, melting point is 0 degrees Celsius, and the boiling point is 100 degrees Celsius. So there are some more shown here as well. But keep in mind, again, that water, does have an unusually high heat capacity. It's an important feature of water, is that the temperature range at which water is a liquid from 0 to 100 degrees Celsius. All right, so that is one of the reasons, again, why water is so special, because it has that broad range of temperatures over which it stays in the liquid state, okay, which is very important because for most organisms, it's important that the cellular water remains in liquid form. So in our cells, we want the water to remain in liquid form. Frostbite or death usually will result if cells freeze or get overheated. All right, so next we're just looking at what happens when a liquid evaporates. So in a liquid, particles are moving at many different speeds. At the surface, so looking at this diagram here, at the surface, some of those faster moving particles will escape into the air. The slower moving particles at the bottom here, those are going to stay in the liquid state. So the slower motion means lower average energy, which means lower temperature. So as high energy particles leave the surface of a liquid, the remaining liquid is cooler than the original fluid or the original liquid. That cool liquid then cools the surface on which it is resting. So this process is evaporative cooling. That's when the faster moving particles on the surface of a liquid, they will evaporate, they will escape into the air. The slower moving particles, they're left behind. They have a lower kinetic energy, so that energy of movement. So therefore, they're decreasing the temperature of the remaining liquid and the surface on which it's resting. Some examples of this, like joggers, they'll feel cold as their clothes dry out after getting soaked in a rainstorm. In homes, homeowners may spray the roof of a house with water to cool the house down on a hot summer day. And another one would be like putting a wet cloth on the forehead of a person with a high fever. All right, so again, when we look at this diagram here, it's those particles that are escaping at the top here, at the surface. Okay, so evaporation cools a liquid because the most energetic particles escape from its surface. All right, we'll watch this video here on changes of state.